Hello. So today we're going to go through our topographic map notes, and some things that you guys are going to hear about are what is a map in general, what we use topographic maps for, details that topographic maps illustrate, and then we get into the details like the contour lines and contour index, a contour interval, how they illustrate rivers, streams, peaks, valleys, and hills, and how to compare a topographic, a land formation from its profile perspective, from its side view, versus a bird's eye or aerial view from the topographic perspective. And then we're going to learn how to calculate elevation by reading a topographic map. So the first thing we're going to talk about is what is a map. Okay, it's a representation of something. We use maps for stars, to track and predict weather patterns, and then you have a map of the capital. If you're on campus, you have campus maps. Now in middle school, we use our campus maps for fire drill routes. So we know the safest and quickest way to escape the building in case of an emergency. In high school and college, you might use campus maps to navigate through the building and through campus so that you can find your way. So a map is a representation of something, and it can be a representation about anything. It's the use of it is different. So you guys might most often use this in video games like Fortnite, Call of Duty, Minecraft. You have mini maps, and they're usually topographic, especially in like the game Zelda. In the game Zelda, it's a true topographic map where you can see the different elevations of hills, valleys, rivers, lakes, castles. You can see all of that on a topographic map. But we use maps to navigate in all parts of our life, whether it's through your GPS, whether you're interested in constellations and tracking planets, or whether you like to watch the Weather Channel and know when a cold front's coming in so you know, hey, I need to wear a jacket tomorrow. There's a lot of uses for maps. So on that note, a topographic map is going to show you basically take a three-dimensional image and put it on a flat piece of paper, on a two-dimensional piece of paper. So we can illustrate a mountain range, a bunch of different mountains, the highs and the lows of all these mountains, but on paper. So they do that by drawing these lines. And you see this overwhelming group of lines with all these numbers. This overwhelms me. It gets easier the more you practice it. But each one of these lines represents a point of elevation on this mountain, right? And mountains, you're going to track the elevation around it. So that's why one of the reasons why we see these circles. Okay, it's almost like we're looking at a black and white version of this landform from an airplane, or if we were a bird. And so these maps have these lines called contour lines, and they tell you the elevation. So a topographic map is useful because it represents three-dimensional images of the land. So again, topographic maps just show the location and shapes of all these mountains, valleys, plains, streams, wooded areas, roads, buildings, and pretty much any other feature you can think of. In fact, on your test, you're going to have an image similar to this one where you're going to have to look at this and determine what topographic map matches it. And we'll get into practicing that later. Topography is basically the making of these maps, how they're made, the people that make them. It's the configuration of the land surface. So they have to go and they have to track all of these elevations to map them. And the images you see, here's like what a map of different valleys look like. So you get all of these weird V-looking shapes. They're real big and spread out. And then on the right side, they're like more squiggly instead of V-shaped. And this is how they illustrate hills. The middle picture I like a lot because you see a profile and you see an aerial view of a topographic map. And it's showing you how they calculate the elevation. So they mark all the points of the elevation on its profile, the way I would be looking at it if I was standing right in front of it. And then they draw those circles as if they were drawing it all the way around. They draw these rings and they mark the same points of elevation to show how the elevation is increasing as you move up the mountain. And if you were to compare these two, you would see this one has much more rings because it is taller. This one does not have as many rings, and its top part is bigger and flatter because that's what it looks like. It's not as tall as this mountain, and doesn't have a pointed top like this mountain. Now, we're going to jump into the vocabulary, okay? So these are some words that I would definitely star or write down. A contour line is an imaginary line on the surface that connects points of equal elevation. And so I stated this already before. A contour line connects points of equal elevation. If you walk along a contour line like my mouse is moving right now, your elevation will not change. Okay, you have to change lines. You have to go to a different contour line to change elevation. So all along this bolded line, I'm going to be at 100 feet in elevation. If I go to this line, I'm now at 75 feet elevation. Okay, so a contour line connects equal points of elevation, and if you walk along one or you trace along one, your elevation does not change. So this slide tells you about a contour interval. And a contour interval, again, it's the difference between two contour lines. It's the difference in elevation. So if I go back to this slide, this contour line has an elevation of 100, and this contour line has an elevation of 75. So the contour interval is the difference between the two. You subtract. So 100 minus 75 gives you a contour interval of 25. So each line of elevation for this particular map is changing by 25. Okay? And again, it is the difference between lines of elevation. And then here we talk about a contour index or index contour. And if you notice on this example, they don't label every single line. Okay? It's almost like we're graphing. When we make graphs, we don't label every single line. We'll label 5, we'll go up 5 more, we'll label 10, we'll go up 5 more, label 15. We only label them in intervals, and that's what they do on topographic maps. So these bolded lines, your index, is for your reference. Index is the same thing as reference. In books, the index is where you go to reference certain things. Or where they reference, the book, the author references certain things to see who they referenced. So the index on a topographic map is for your reference, and it's going to tell you, for example, this bolded line is 7,000, and this bolded line is 660. If you know, you can calculate the difference between these two, and it'll help you calculate the contour interval, and we're going to practice that in a minute. The contour index occurs every 5th line, and it really helps to read the elevation on the map. It makes it much easier to determine elevation. So again, the contour index occurs every 5th line. That is an important vocabulary word. Contour line, contour interval, contour index. Those are 3 important vocabulary words. The contour line marks the points of elevation. The contour interval is the difference between those points of elevation, and your index is every 5th line to help you figure out what the elevations are. Okay, it's much easier to label those index than to label every single contour line. So an example, if the contour interval on a map is 20, then your 100 meter, 200 meter, and 300 meter contours will be the index. They'll be what are bolded. Okay, so your index is the bolded line, and it always occurs every 5th line. So here it's asking you, what is the contour interval? How many feet is the map increasing by? So we're going to reference our contour index, which is are these bolded lines. Okay, and there's 2 ways that you can go about doing this. This line is 700, and this line is 800. And remember, our index occur every 5 lines. So I'm going to take the difference of 800 and 700. I'm going to subtract them. So the difference between 800 and 700 is 100. So there is a 100-meter difference between this index and this index. And there are, from 700 to 800, there are 1, 2, 3, 4, 5 lines. So 100 divided by 5 is 20 feet. So each line is increasing by 20 feet. Another way you can do that is I just need to plug in numbers and count. So the way I like to do it is I'll say 700, 710, 720, 730, 740. No, that can't be right because I have to get to 800. So then I start over. 700, 720, 740, 760, 780, 800. I kind of plug in those numbers and count up to 800. Okay, just like you would do on a graph. So again, probably the easiest way is to take the difference of your contour indexes, 700 and 800. The difference is 100 because you subtract them, and then you divide by 5 because there are 5 lines until you get to the next index. So again, we start at 700, 1, 2, 3, 4, 5. So you divide by 5. What you're going to do is you're going to look at this. We already calculated the contour interval for this map on the previous slide. So now you need to use that interval and determine the elevations at each one of these points. Now, a very important note, you look at C and it's not on a line. That means you have to estimate what it would be between this point of elevation and this point of elevation. If it is not on a line, for example, if it's not on a line, you cannot say it's that point of elevation. You're going to have to estimate a little bit. So our contour interval is 20. Each one of these lines is increasing by 20. Point A is directly on the 700 contour index mark. So this bolded contour line, this is our index. A is 700. A's elevation is 700. And they increase by 20. So this is 720. And that means that B has to have an elevation of 740 because it is directly on this line. The next line is 760. And then the line after that is 780. So C has to have an elevation between 760 and 780 because it's not directly on either of those lines. It's somewhere in between. So our best estimate is 770 because it's so much in the middle between these 2 points. So we have 760, 780, and so we're saying C has an elevation of 770 because it is in the middle. And then finally, D is one line after this index. So this index is 800. Each line increases by 20. So D has to have an elevation of 820. So when we read topographic maps, they illustrate other land formations like valleys, hills, and streams. Usually they'll have this blue line, but for your practice purposes, you guys aren't going to see very many maps with this blue line. That illustrates where that stream is. These last 2 bullet points are the most important. When a contour line crosses a stream, it looks like an upside down V. That's really important. It does. You see that upside down V shape, or U shape almost, all through right where this blue line travels. Okay, so the V points upstream. So this bottom part, the closed part, is pointing upstream, and the opening of the V is open to the direction that water is flowing. So water is flowing downstream, and so the opening of the V is going to be pointing downstream. Is another way to restate that. Remember that streams and rivers flow downhill. They always flow from a higher elevation to a lower elevation. The point of the V is always going to be pointing uphill or upstream. So right here, you see this V shape and this right here. This is where your stream would be. All of these upside down V's. And so up here is where the stream starts and it's flowing down because the opening of the V points downstream. This will take a little bit of practice in identifying this. So the next part is identifying depressions, and these are actually the easiest to identify because they have these little tick marks, these hatch marks that you see, and what it's telling you is that the elevation is decreasing at that point. So that's basically you have a massive crater or a sinkhole or a dried up lake. It's not a body of water. They represent those different. When you have these depression contours with these hatch marks, it's saying that you have a giant empty hole of nothing. Okay, it's telling you that elevation is decreasing inward. So if you look at this bottom example, it goes from 60, 50 into 40. It's telling you that this is a hole of some kind, a dried out hole of some kind, whether it's a crater or a dried up lake or a sinkhole. This is a hole. Okay, and you know that from these little tick marks or hatch marks. They look like thorns, honestly. And then the last couple things that we're going to talk about are hills and valleys. So hills, you have these more squiggly shaped lines. It's a very rough circle. It almost looks like you drew circles with your non-dominant hand. So I'm right-handed. This is probably what it would look like if I drew a topographic map with my left hand. And then valleys. Valleys have more sharp triangle V-looking shapes around them. The last two vocabulary words that you guys need to pay attention to are steep and gentle. So steep is a lot easier to identify where it's almost vertical. Okay, so we talked about steep when we talked about distance time graphs. So steep, it's going to be very, very tall, almost vertical, almost a straight line. Whereas gentle, like I think it would be, the way I look at it is it would be safer to roll down a gentle slope because it's more level and more flat. It wouldn't hurt versus a steep slope that would probably not end so great. That would hurt really bad if I were to roll down this side, the steep side of this hill. And what's cool is when you look at a topographic map, the steep slope can be identified by the closeness of the lines. So the closer your lines are, the steeper it is. And the more space in between your contour lines, the more gentle it is. So I'm going to say that again. The closer your lines are together, the steeper it is. When you have a lot of space in between your contour lines, it's more gentle. So this diagram is showing you the profile view and the topographic view. So you can see this is really steep when you look at it from the side. And when you look at it from the top, they illustrate that by putting the lines really close together. And on the gentle, it's very flat. You could slide down it really easily and safely. It would probably be kind of fun. And you look at the bird's eye view, the aerial view, the lines are very spaced apart. So you guys are going to have to be able to look at a topographic map and identify the steepest side of the map and the gentlest side of the map, or the gradual slope. So I would rewatch this video just so that you can make sure that you hear those vocabulary words again. As far as this activity, let's answer these questions. So what is the contour interval? So when we look at this map, this line's 25 and the very next line is 250. And then the very next two lines are 275 and then 300 and 325. So if we subtract 250 and 225, we're going to find that our contour interval is 25. So each one of these lines is changing by 25 meters. The lowest elevation we saw was 225, and our highest elevation, these are our plateaus or our peaks, is 325. Okay, so our lowest is 225 Our highest is 325. The difference between location A and B. So this is something else you guys are going to have to do. A, if we trace this line, is on 275. Okay, so you have to trace that. A has an elevation of 275 and B has an elevation of 325. So to calculate the difference between A and B, you will need to subtract. And somebody said it was 50. Good. And then it said how many peaks does this mountain have? So if we look at our map, here's a peak, here's a peak. So it's got 2. And then it says which geographic location is the steepest. So we want to look for the lines that are closest together. These are pretty close, but if you look right here, that 275, 250, it's a lot closer. So the closeness of these lines indicate that the northwest side of this mountain is the steepest. And our gentlest, gradualist side is going to be with the most space, which is over here. So you could say south or southeast. Southeast side is gentlest because it's got the most space in between each contour line. And then finally, what is the difference in elevation between the two hills? Well, if we look at our map, the top of this hill is 325 and the top of this hill is 325. So there is no difference. They are the same elevation, okay? And these are the responses from Tuesday's Check for Understanding. So if you didn't do well on Tuesday's Check for Understanding, after watching this video, go back and fix it.